Let's now talk about Lockwait. You have already seen how Lockwait works when we talk about cursor stability without currently committed. Let's revisit that example. Application A perform an update taking an X-lock. Application B wants to read from the same row, which would take an S-lock, but it cannot since X and S locks are not compatible in CS without CC. Therefore, application B must wait. How long will I wait? This is set by the parameter lock timeout. By default, this parameter is set to -1, which means infinite wait. Moving on, let's now talk about deadlocks. The example shows how a deadlock occurs. Note that the operations within app A occur within one transaction. Similarly, for application B, this is important to note because, for example, if application A was doing an update and then it committed, it would release all locks and we would have a different scenario altogether. Application B performs an update, so takes an X lock on row with seat 7C. The row is updated with John, though the change is not yet committed. Application B performs an update on another row. The one with seat 9F is also will take an X lock on this row. The row is updated with Su, though the change is not yet committed. Application A issues a select on the row with seat 9F, so it wants to take an S lock on the row. Application A hangs. It has to wait since application B has an X lock on row with seat 9F. Application B issues a select on the row with seat 7C, so it wants to take an S lock on the row. Application B hangs. It has to wait since application A has an X lock on row with seat 7C. So we have a deadlock. Application A is waiting for application B to release its lock before it can continue, and application B is waiting for application A to release its locks before it can continue. Note that in this example, we are assuming that we are using isolation CS without CC. Normally, deadlocks are situations that happen due to bad application design. DB2 has a deadlock detector that checks every X the number of seconds. If there is a deadlock, X is set by the deadlock check time. DB2 CFG parameter when the deadlock detector detects a deadlock. DB2 will use an internal algorithm to pick one of the two applications that is causing the deadlock, and it will roll it back. The exact SQL error the application that is rolled back receives is SQL code -911. SQL state for 0001 with reason code 2, where reason code 2 means the transaction was rolled back due to a deadlock. The other application will be allowed to continue.